Algebra 2, Section 2.3, direct variation. Direct variation is given to us with a formula that's quite simple, y equals kx. This is in slope-intercept form, believe it or not. Y equals mx plus b. They just picked a different letter to put in front of x, and then also the y-intercept is 0, so that we don't bother with the plus anything here. It is in slope-intercept form, it's just that the b value would be 0. They could have made a different decision and decided to put m in here, but our book uses k, so I'm using k here. Okay, that's what's normal for the constant of variation in direct variation. In fact, let's go ahead and label that. The k value is what's known as the constant of variation. Now think about this. Think about a problem that said, find the direct variation equation for a line that passes through the point 2, -3. Okay, just for starters. And you might think to plug 2 in for x and -3 in for y. That would be a smart thing to do. Don't stop there. You're not going to get any points by just plugging stuff in. Teach a young person to do something like that. This is high-level math we're doing here. What you want to do is solve for k and then plug that number back in for k. You're actually finding the constant of variation and then plugging it back in, and that would be equation that is direct variation that passes through that point. So let's do that. You would divide both sides by 2. You'd find out that k is -3/2, the fraction -3/2, and then you could rewrite this equation as y equals -3/2x. This is an equation that is direct variation that contains this point. It would be overkill, but you could plug 2 in for x and see that you get a -3 as an output for y. So now you know 2 points that are on this line. Not only do you know the given point that was 2, -3, you also know that the origin, because the y-intercept is 0. Okay, and look that the origin works too. 0 in for x would produce a 0 for y. So these would both be on that line. And we could do this again with a different point. You come up with a different equation. But think about this now. Each time what you would do to get k by itself, to find out what k is, you're dividing by that x. We divided by the 2 here that we had plugged in for x. So why don't we just in general take y equals kx and divide both sides by x? You'll find that k is equal to y over x. Okay, so if you can remember that, you really don't need to do this kind of calculation. Just take the y and divide it by the x, if you can remember that, and that's kind of an important if. Otherwise, do what I did at the first there and do two lines of work. But the k value is the y value divided by the x value always. Okay, so let's look at an example. There's just a few different ways that they'll ask the direct variation question. The concept is very easy. They'll just ask it in different ways. For each function, determine whether y varies directly with x. If so, find the constant of variation and write the equation. Okay, so I'm looking here, and what did I just show you? That you can divide the y by the x. In that first table, if I divide the y by the x here, 3 divided by -1 would be -3. If I divide -6 by 2, I get -3. So far, so good. Oh, but when you divide 15 by 5, it's +3. That's not constant. This is not direct variation because that's not a constant of variation. If we had gotten the same number each time for all of them, then that would have been your constant of variation, and the answer would be yes, this is direct variation, but this one is not direct variation. And I'm not going to abbreviate this dv because we already have an abbreviation for dv, dependent variable. But this is not direct variation. So then take 14 divided by 7, you get 2. Take 18 divided by 9, you get 2. Take -8 divided by -4, you get 2. Here you do have direct variation. And again, not only did you determine that, yes, it is direct variation, you also determined what the constant variation is. It's 2. So you can simply write y equals kx with 2 in for the k value. Y equals 2x. Now understand that if you plotted these points, on the coordinate grid, they would all form a line, and the line would pass through the origin. If you plotted these points, they would not be a line that passes through the origin. Could be a line, could pass through the origin, but that would be, have to be some curve or something, because this is not direct variation. Next one. For each function, tell whether y varies directly with x. If so, find the constant of variation. So it's kind of the same directions, but the look of it is very different. Basically what they're saying is, can you make this look like y equals kx? Well, the key characteristic here, just as with slope-intercept form, is that y is by itself. So we could go ahead and divide by 3. That means divide all terms by 3, and you'd have y equals 7/3 x plus 7/3. Does that look like y equals kx? Nope. It's in slope-intercept form, and the b is not 0. Okay, so this is not direct variation. Okay, here our variables, our y, we want to get y by itself. Our y is being multiplied by -2, so you go ahead and divide by -2. And I'm going to flip it around, so it's y equals, this would be -5/2x. I like to have that number out front rather than saying -5x/2. Have the negative out in front of the fraction, have the fraction here, and then x, because now we can just pick that k value out. It's this right here. So the constant of variation is -5/2. And next, the perimeter of a square varies directly as the length of a side of the square. The formula P equals 4s relates the perimeter to the length of a side. This is in direct variation form. This is y equals kx. It's just that the input, they're using s instead of x. The output, they're using p instead of y. And it's very true that the perimeter of a square varies directly with the side. As the side gets longer, let's say, the perimeter would get proportionally the same, longer. So find the constant of variation. That's just a simple pick it out of the equation. It's 4. K is 4. And then find how long a side of the square must be for the perimeter to be 64. So we could take our equation, plug 64 in for P, and then just solve for S by dividing both sides by 4. The side is 16 centimeters. Okay? Now listen, all of that was nice. And it all leads up to this classic direct variation problem. This is what we really want you to be able to do. Suppose y varies directly with x and y equals 15 when x equals 27. Find y when x equals 18. Now, I'm not a big fan of this direction here, so let's just find y when x equals 18. First things first, when they use this language, y equals 15 when x equals 27, you got to think ordered pair. This is 27 comma 15. When y equals 15, x equals 27, that's an ordered pair, 27 comma 15. Okay. Now, the way I like to ask this question when it's on a quiz is sometimes I'll ask for the k value. There'll be an answer blank on the quiz or the test for k, and then I'll ask for the equation. And then I'll ask for you to answer the question. When x is 18, y is equal to what? Okay, so this is a possibly 3 or 4 point question, probably 3. If it was 2, it'd be half, 1 probably, but I could see this being a 3 point question easily. And again, what you need to do is to find the k value, divide the y by the x. So that's simply 15/27, and then reduce that. Please reduce your fractions. Both of these are divisible by 3. That means 5/9. The k value would be 5/9. On the quiz, that's probably worth a point. Okay, that's a 9. The equation then is y equals kx with 5/9 in for the k. And then, again, what we really need you to be able to do is this. Take that equation and answer this question. Find y when x is 18. Y equals 5/9 times 18. Well, that would be 10. And let me say what I said before on a previous example. You now know 3 points that are on this line. This is a line, and it passes through 27/15. We now know that it passes through 18/10, right? X is 18, y is 10. So 18/10 is another point that it would pass through. And the origin is also a point that this would pass through because it's direct variation. And if you want to, plot it out yourself on a piece of graph paper, you would see these 3 points on a line. They would form a line. Okay. The last thing I want to show you is something on the graphing calculator. It's time to start doing some things on the graphing calculator. I've been asked a few times now, where's the fraction button on the graphing calculator? There isn't one, but it still functions. It still can function that way that the fraction button does on the scientific calculators. And here's what you do. Let's suppose you want to multiply these two fractions, 5/9 times 3/8. Rather than going 5 fraction button 9 times 3 fraction button 8, you're just going to use the divide key. This key right here is what caused the slash there, the divide. Now, of course, I've told you in class that I don't like slashes for fractions, right? But your calculator has to do that. I like top over bottom horizontal fraction bars. But here is let's just say these are two fractions you want to multiply, and you want to give a fraction answer. You go enter, and it gives you a decimal answer. So here's the first keystroke I'm going to teach you on the graphing calculator. Math, enter, enter. They don't get much easier than this. Math, enter, enter. Push the math button, and then enter will select this, which is fraction, and then you're back to your calculation screen, or some people call that the home screen, and then press enter again, and it'll do it, and it converted that decimal to a fraction. So that would be 5/24. 5/9 times 3/8 is 5/24, and the good part about it too is it reduces the fraction for you. That's not a replacement for you being able to reduce a fraction, but it is a shortcut for you if you have the use of a calculator. Thanks for tuning in.